All right, welcome to the lecture today. We want to learn more about level measurements. Last time we started the discussion on level measurements. That's very important in industries where you have storage of materials. And so, for that reason, uh, fluid stored in large containers cannot be measured easily manually. So there's a system by which it can be measured automatically, electrical, electronic, mechanical systems. And these systems and what we term as level measurement systems. So last time we discussed about level measurement system, resistive method, and then a float method. Today, we're going to learn more. We're going to talk about two other methods or three other methods. One, force balance diaphragm method. The second one is bubbler or purge system. The last one is capacitive method. So we want to look at this. So thank you for joining the class. We want to move on straight without wasting time into the discussion. I can see a few of you that are here already. Please inform them that we are live. Let them join so that we can follow together in this lecture. So the first one we are going to discuss is the force diaphragm method. Force diaphragm method. I hope you are following. Force diaphragm method. So what is a force diaphragm method? Talking about force diaphragm method, we between the hydraulic level and the liquid column in a container, in a storage tank. Now, when we have liquid in the storage tank, and then it is not full, there will be empty space on top of the liquid inside the tank, and then there will be liquid at the lower portion. So there's a system that is going to determine the pressure, which pressure we are going to use to determine the height of the liquid in the tank. So there's a small device attached to the tank that is connected between the liquid and the top of the tank. Talk about differential pressure. We are talking about measurement of pressure of two bodies that are related, but they are having different pressure. So there's going to be a pressure difference between the two parts of the system. And that is what we term differential pressure. Difference in pressure is going to be measured, and the value of the difference is going to be indicated. Now, the differential pressure is measured between the liquid and the empty space, maybe air, on top of the liquid in the tank. Now, this on top of the liquid in the tank. Now, this differential pressure is used to determine, based on the density, variation in temperature and mass density of the fluid, to determine the height of the fluid or the liquid in the tank. The actual height of the liquid column is determined based on the density. You know, density is a mass divided by volume, and volume is area of the area of the tank, the multiplied by the height of the liquid in the tank. Now, the sensor used for the measurement is a differential pressure cell, and then it's using a special corrosion material for the diaphragm. Now, this method of liquid level measurement gives very accurate results. Very accurate results. So it's a system that gives high accuracy and a greater resolution because it's using pressure to determine the height of the liquid. The pressure will actually determine the volume of the liquid in the tank. And from volume with density, because density of the fluid is known, then the height of the fluid can be determined. That is a very ingenious system to measure the height of the liquid in the tank by using the differential pressure between the level of the liquid and the the space, the air on top of the liquid in the tank. So when the liquid fills up the tank, it means there are going to be less pressure difference, less pressure difference. So we're going to have high pressure reading, which is based on the liquid. Now, when there is little liquid in the tank, it means there's going to be high pressure difference between the liquid and the gas on top, that is the air, the empty space on top of it. And that will be used to determine the height. So the results will correspond for when the results will correspond for when the tank is full and when the tank is empty, or in between these two extremes. All right. But we said this system of liquid level measurement is very accurate and provides greater resolution, but also has its own demerits. The demerit lies in the high costs of construction. That is, when you compare this construction to previous system that we have discussed, this is quite expensive to construct. The high cost of construction makes it to serves as the disadvantage or demerit of the system. So that is how the uh, the differential pressure method of measurement, that is how it works. The force balance diaphragm method. Force balance diaphragm method. That is how it works. Now, I wouldn't know whether anyone here has a question. You can actually ask your question. If anyone has a question, you can actually ask your question. So I could see that you people are already here. So if you have any question, you can ask your question. But if there's no question, we can go to the next one. If you have any question, you can say something in chat. Let me see your comment in chat, your question in form of a comments in chat. Let me see it. But if there is no question, we can move on to the next uh, system that we want to discuss. That is a bubbler or purge system. Bubbler or purge system. Now, briefly, I can describe, I can sketch the system that we just discussed on the board here, on the whiteboard, so that you can have an idea what we are talking about. So I want you to pay attention to the board to see how the system looks like, the sketch. All right. So we have the system like this. We have the tank, and inside the tank there is fluid. There is fluid at this level. This is height of the fluid. And here we have air that is not there's no fluid air. So you can, let me use another color for that. You can distinguish that is air. Now, the differential pressure measuring system is attached to upper and lower parts of the tank, so that the system can determine the difference in pressure between the fluid and the air. So this is a differential pressure measuring device. Okay, so this is what happened. So the fluid air has a density, density is based on mass and volume, and that density will ensure that there will be a difference in pressure, since this is ordinary air, that it doesn't have such density as liquid, since it's ordinary air. So the measurement of pressure here will be different from here to here. So the difference in pressure will be converted you know, with the value of the density of the fluid that is known, the height of this liquid will be determined. That is it. So that's the simple system there. So and it's highly accurate, highly accurate. Now we want to talk about the bubbler or purge system. Bubbler or purge system. Okay. When we say bubbler, we are talking about something that bubbles. You know bubble? When you carry a small pipe and then you put it inside a container of water and blow air into the small pipe, the air will create bubbles into the water, and so that the bubbles will be coming out from the water. So the system for measurement here is working in similar way, bubbler or purge system. In this bubbler or purge system, a pipe is inserted into the tank, into the storage tank that contains the liquid, and it's inserted such that it reaches almost to the bottom of the tank, just a few centimeters off the bottom. Now, there's a system by which air is introduced or some other fluid is pumped into the pipe that is inserted into the tank. All right. Now, when the air goes down through the liquid through the pipe, then it will be coming out from the bottom of the tank. Then it will be rising up through the liquid, coming to the surface of the liquid. Now, when bubbles are able to escape to the surface of the liquid, at that point, the pressure that the device that is bringing the bubbles in have at that point will be equal to the hydraulic head, that is the pressure head, due to the height of the liquid. When it bubbles, the air pressure in the pipe is equal to the hydraulic head of the liquid, and it can be measured. This can be measured with a differential pressure transducer. Now that pressure at that point will be computed using the mass density of the liquid, just like the previous system that we discussed. The density of the liquid will be used to determine the height of the liquid, since density is mass over volume. Remember, density is mass divided by the volume, and volume is the cross-sectional area, that is the base of the tank. If it's a circular tank, it's going to be area of a circle multiply the height by the height, and that gives the volume. If it's a rectangular or square type, length and breadth area of that base multiplied by the height gives the volume. So that volume will be needed to determine the height, since density is mass over volume. So mass density of the liquid is going to be known, and so when this device introduces air bubbles into the system, when it bubbles, the pressure of the incoming air equals to the hydraulic pressure head of the liquid. And at that point, the value of the pressure will be recorded. Now, the pressure measurement will be converted to the height of the liquid by using the mass density of the liquid. So it's very similar to the bubbler, to the force diaphragm system that we first discussed. So they are working with the pressure in the liquid to determine the height of the liquid. Very straightforward. So the computation of the height of the liquid level is gotten from the pressure measurements, which is actually related to the density of the liquid. So using the mass density, the height of the liquid can be calculated. So that is how the system works. So that is how it works. Very simple and straightforward. It's going to also give a accurate results. So that is the second system for today. Second system for today is a bubbler or purge system. So So at this juncture, I would like to know if there is anyone here that is having any question so that we can quickly look at the next part of this lecture. Does anybody have a question? So if you have a question, you can type your question in chat. You can type your question in chat. So if there's any area in the two parts that we discussed, so we can quickly, if there's any area that is not very clear, we can quickly go over it again before we move on to the next one. All right. So I'm waiting for any question. I will wait briefly like this for maybe some seconds before we move on. Okay, still waiting. Okay, I've not seen any question here. Not seen any question. We want to move on to the next. And the next system today is the capacitive method of level measurement. Capacitive method. Now, the capacitive method of level measurement is another technique by which the height of the liquid in the tank can be determined. The capacitive method. Now, the arrangement is a design whereby a high frequency electrical signal is delivered to a sensor, and the magnitude of the current through the device is dependent on the capacitance of the material and the depth submergence of the probe. Now, the system is designed such that the tank is formed as two concentric cylinders. Two concentric cylinders. Uh, I I want to believe that you understand what we mean by two concentric cylinders. When we have a can, for instance, a beverage can like Bonvita, like Milo, and then you have it put down on the table, you know, then you have a smaller size of it, but of the same height. The smaller size is inserted into the bigger one so that the two of them have seats, we call them concentric circles. And then they are seated in such a way that the space around the smaller can is, uniform round the bigger can. So in that situation, we have two concentric tanks. So the system of capacitive measurement is designed in such a manner so that we have two concentric cylinders. The tank is designed as two concentric cylinders, but it's designed in such a way that the inner cylinder is having opening whereby the fluid can escape into the outer cylinder, the bigger tank. So the smaller tank is designed in such a way that the fluid can escape into the bigger tank. Now, when you have this system, then a high frequency signal, electric signal, is passed into the two containers so that the capacitance is developed in between. A capacitance is made when we have two parallel plates and dielectric between them. Two parallel plates and dielectric between them. When you have that, then you achieve a parallel plate capacitor. Now, the parallel plates here, they are the concentric cylinders. That is the tanks, the bigger tank and the smaller tank that are placed inside each other. Now, as they are placed inside each other, the wall of the tank, they are parallel. Since they are both cylinders, they are parallel to each other. And then the space in between is uniform. They are placed such that the space in between the smaller tank and the bigger tank, that is the cylinders, is uniform. So in that case, capacitance is developed. Now you might ask, you might wonder, what is now the dielectric between them? The dielectric between them can now be either the fluid in the tank or air, when there is no fluid, the portion that doesn't have fluid, we have air that is above the fluid. Then air will serve as dielectric for that portion, and then the fluid will serve as dielectric for the portion that the fluid is filled. The fluid has filled in the tank. So in that case, we are going to have two different capacitance developed. Now, let me quickly sketch what we are talking about so that you can see it for those that don't have the notes. We have the bigger tank like this. This is the bigger tank. Now, we have another tank inserted into it. Let's say this is the wall of the bigger tank. Another tank is inserted into it. So when you check the cross section, we have something like this. If you cut it as a cross section, we have something like this. But the system is designed such that the smaller tank has an opening or openings, many openings, whereby there will be passage of the fluid into the bigger tank. All right? There will be passage of the fluid into the bigger tank. Now, electric signal, high frequency electric signal is now connected like this, such that if you measure between these two, wires, then you will see we obtain a capacitance. Now, the capacitance obtained, a parallel plate capacitor, capacitance value is given as C equals EA over D, where E is permittivity, A area of the plate, and D, the distance of separation. Now, E, permittivity, depends on the type of dielectric that we use in the tank. In this case, we have two types of dielectric. We have fluid at the lower part like this, or sometimes maybe the fluid gets to the full, to the upper part of the tank. But let's assume at this instance, it does not get to the upper part of the tank. And so for that reason, we have two different dielectric. The fluid, yes, and then the gas, which is actually air on top. Air at this portion also serve as a dielectric. For that reason, there's going to be two capacitances formed. One capacitance will be for the portion of air, the height of the air, and then the other one will be for the portion of the fluid in the tank. We have the fluid at this level. So they are different heights. The total height of the tank is capital H. Then we can have H1, and we can have H2, small letter H1, small letter H2. H1 is the height of the liquid in the tank, and then the height of the air in the tank, that the empty space on top, is H2. Now we can have that system in that manner, so that we can have H of liquid, H of of gas or air. Then we also know that because there is two different dielectrics, we have two different permittivity. Permittivity of the fluid, which is dependent on the type of fluid that we have in the tank, and the permittivity of air that is above the liquid. Now, for this reason, we are going to have a complex capacitance. So the total capacitance formed, capacitance C at this point, will be a sum of the capacitance of the liquid, and then the other one, the capacitance formed by the air or vapor on top. You can call it vapor or air. So that the two of them, when added together, we have total capacitance as a complex capacitance, which if we simplify, we can have 2 pi E naught EL HL. We can have C equals 2 pi E naught multiply by, ELHL, ELHL plus EVHV over log base ER2, over RL. Now, the I the board may not display my writing properly. That's why I stopped. It could be inverted. All right. But as you know, it's already in the notes. So, this system will determine the capacitance, the total capacitance thus formed by the liquid on one part and the vapor on the other part. Now, when the total capacitance are summed together, when the two capacitances are summed together, we have the total capacitance developed by these arrangements. Now, the capacitance developed will determine the height of the liquid, because when you look at the formula given, you see that the height of the liquid HL is among the parameters in the formula, so that at the end of the day, someone can calculate or determine the height in the tank. Now, bear in mind that we are going to have two permittivity, the permittivity of the liquid and permittivity of vapor. And apart from this, we have to bear in mind also that we are going to have permittivity of free space in the formula also, 2 pi E naught. And the capacitance thus formed will enable one to determine the height of the liquid in the tank. Again, we also have another dimension in the formula, which is actually the radius. The radius, you know, we have two value of radius. We have R1 and R2. The two of them also uh, determine the calculation in the formula. So when you check that, you now see that the capacitance, determination of that capacitance will help us to know what actually is the value of the height of the liquid in the tank. All right. So I still want to inform you again that those that have not subscribed to the channel, go ahead and click on subscribe. It may be necessary for you to log in with your Gmail account into your YouTube. Use your Gmail account to log into your YouTube. Then, as you link up with the class, whether with the live class or the videos, you can click on subscribe on your account, so that in another time when we are posting videos, you are going to be quickly be notified by YouTube. So that is it. Now, I want to believe that there will be question in this class. All right. See, you said the diagram is not clear. Yes, I can see that. Actually, when you check the notes, the handout for the class, you see the diagram there properly. Or if you want me, I can actually copy it and send it to your WhatsApp now through the rep. You can send it to your WhatsApp through the rep. I can copy all the diagrams, put it on one page and send it to your rep, so that you can share it on the group. If you want that, can you say yes on the group? If you want that, can you say yes on the group? Let me see the yes on the group. Let me see yes on the group if you want that. I'm waiting. If I see yes on the group, then I will do that. Or else, you can check the handouts. The diagram to each system is there. All right. So that is capacitive method. By determining the final capacitance, the equivalent capacitance thus formed between the fluid and the vapor, then using this formula, the height of the liquid can be determined. And then there is a calculation also on the system based on this same formula. I stopped writing the formula because it's going to be inverted, I guess. Is it inverted when you saw it or not? Can somebody answer that question? Was it inverted or it was displayed properly? What do you say? Okay. So now I think we have come to the discussion of the third system, which is actually the capacitive level measurements. Now, there is a calculation based on the formula that we just encountered here, whereby we can calculate the level of liquid in a tank, in a very tall tank containing a particular liquid which is having particular permittivity, and the vapor having different permittivity inside the tank. So when the electric signal, high frequency signal is sent, a capacitance is developed, and then that will be measured, after which we can now use that value to calculate the level of the liquid. So the system is very innovative, very innovative also, and then it's going to be give accurate results because it depends on the capacitance developed between the liquid and the vapor. So that is the capacitive method of level measurement. So gentlemen and ladies, so somebody said yes. So that means I should send the sketches. Is that what you mean? That I should send the sketches? Is that what yes means? I guess so. So I will send the sketches so that you can actually see it on your device. Or later on you can check also your handout. You see the sketches there. Right now let me send the sketches. Okay. I will send the sketches of the three systems that have been discussed so far. The first one was force balance diaphragm method, and the second one is the bubbler system. Bubbler system. Okay. Now, the last one is the capacitive method. All right. Last one is the capacitive method. So I'm going to send the sketch of the three of them to the WhatsApp through the HOC now, through the rep, the class rep, so that you can have that. Okay. All right. Now the third one is a capacitive. I'm going to copy the third one now. So the three of them will be sent together. And now I guess we have clear understanding of the three systems discussed so far today. If that is so, can I hear, can I see your yes? Can I see your yes on the chat? Let me see your yes. If you actually understand the three systems discussed so far today, can I see your yes? Okay. Type yes into the chat box. Type yes. All right. Let me see how many yes we can get. For those that actually understand the discussion today, let me see how many yes we can get. Okay. All right. Let's see your yes, and then don't forget you can also ask your question along. I like to respond to your question right now. If you have any question, I want to respond to it right now. I want to respond to your question. So the HOC has the PDF of the three sketches sent to Olawale right now. So Olawale, check your WhatsApp and you can forward it to your colleagues. Now, I want to see your yes that you actually understand the discussion today. I see yes and I also see no. Okay. So those that said no, please let me know what area you want me to go over briefly before we end this class, because these are the three systems that we want to discuss today. The first one, according to the sketch I sent to you, is force balance diaphragm system. The second one is the bubbler or purge system. Bubbler or purge system. And the last one is the capacitive method of liquid level measurement. All right, I could see some few guys are saying no. All right, I will go over each of them briefly before we end the class. And then it will be an advantage for those that were here from beginning to also learn more, understand it better. All right. So the first diaphragm method is a system of measurement whereby a differential pressure is used to check the the hydraulic height, hydraulic head of the liquid in the tank. When you have liquid in the tank and then it's not completely filled, there's no way you can actually completely fill the tank. So we are going to have differential pressure between the liquid and the empty space, that air or vapor on top of the liquid. Now the differential pressure is set up such that it's going to measure upper part of the tank, like you can see on the whiteboard, and the lower part. The lower part has fluid, upper part has vapor or air in the tank. So there's going to be a difference in pressure. So a differential pressure device is attached to the tank like this. And so because there are two portions in the tank which are not the same, which are not the same liquid, and then they are in the same tank, the differential pressure device, differential pressure measuring device will be able to pick up, the difference in pressure between the liquid and the vapor. And that will be used to compute the value of the height. Since density of the liquid is known, and we know that there's a relationship between density and volume is related to height of the liquid. Volume is area, that is base area multiplied by the height. So with that, the value of the differential pressure measured will be used to determine the value of the height of the liquid in the tank. So the sensor used is a differential pressure pickup. Differential pressure pickup. That's the device you see here. This device here, it's a differential pressure pickup. It's checking the upper and the lower parts of the tank to determine the pressure difference between the two parts. And that pressure will be converted to liquid level using the density of the liquid, which is related to the volume and then indirectly related to height also. So that's the first system that was discussed. And the second system that was discussed was the bubbler or purge system. No, that explanation gave an advantage, for both people that were here at the start, at the onset, and also those that joined later during the lecture. Now, both of you should have a clearer understanding of what that system is now. Now, right now, because of network data that you're actually using, I don't want us to stay for too long. I'm going to go over the bubbler or purge system now. I'm going to explain it. Bubbler or purge system is a system whereby there is, fluid in a tank and a pipe is introduced into the tank to the bottom of the tank with only a few centimeter left for the pipe to reach the bottom of the tank. Now, there's a system by which air bubbles or some other fluid bubbles is introduced into the tank. When the bubbles are introduced, there's a system that is measuring, the pressure of the air bubbles that is coming into the tank. Now, when the bubbles goes into the tank, if it's able, the bubbles are able to go to the bottom of the tank, enter into the liquid and come up and bubble. At that point that it bubbles at the top of the liquid, the pressure of the air introduced is equivalent to the hydraulic pressure head of the liquid in the tank. And so for that, the pressure measurement by the pressure measuring device will be used to calculate the liquid level using the mass density of the liquid in the tank. Because the mass density of the liquid in the tank is going to be known, so that job is going to be easy. So the liquid level will be measured by the determination of the liquid level that has been measured. So that is it. The air pressure in the pipe is equivalent or equal to the hydraulic head of the liquid, and this can be measured with standard differential pressure transducer. All right. So the liquid level is computed using the mass density of the liquid. So that is how the system works. The system works in the computation similarly to the first one, the forced diaphragm system, that actually uses density, differential pressure, to calculate using the density to calculate the height of the liquid. In the same manner, the differential pressure, the hydraulic pressure of the liquid is determined by introducing bubbles, air bubbles, into the tank. And the device is actually a differential pressure transducer is determining the bubbles that is coming. When the bubbles is able to, escape to the top of the liquid, at that point, the pressure of the bubbles coming equal to the hydraulic head of the liquid. So that pressure will be used using the mass density of the liquid to determine the height of the liquid in the tank. And that is how the system works. Very straightforward. And the last one that I discussed is the capacitive method level measurement method. All right. So the last one now, somebody is mentioning here that he wants this lecture to be saved. Sure, this is a YouTube live stream lecture that we are having. Immediately we end the class, in about 5 minutes or so, YouTube will make it obtainable in my channel. So I will go online, copy the link to the video and send it to you guys so that you guys can actually watch it. And those that were not able to attend the class also can watch it. Then the video will be there. I don't have intention of removing them from my channel. So you have the opportunity to log in and watch them over and over again to actually listen to the explanations that's been made and refreshing your knowledge, your memory on the concepts that we discussed. So that's how it is. So even the previous lectures, they are still there in the channel. So I will resend even those ones too. If you guys don't have them, I will send the links so that you can watch them over and over again. The lectures are available online on YouTube, on my YouTube channel. And then for you to quickly remember the channel is very easy. Just type youtube.com/@electro_teach. youtube.com/@electro_teach. That is the channel. That is my YouTube channel. So I can quickly type it here so that you can see it. youtube.com/@electro_teach. So you see it on your screen now. I just typed it into the chat so that you can see. By the time you click this link, it takes you to my channel whereby you see all the videos of the lectures. But the only thing is that you will have to select a particular video you want to watch. There are other videos for other courses also available. There are other courses, other lectures available, such as computer lectures, such as electronic lectures, such as mathematics, statistics, depending on which lecture I'm giving. Now, even you guys can actually request sometimes. If you want me to give like mathematics lecture, you can give me a topic to give. Then I will surely try and prepare for that and give the lecture and make the link available to you guys so that you guys can actually use that as another opportunity to learn more from your your method of level measurement. In this method, we have the tank containing the fluid designed as two concentric cylinders, one bigger cylinder and one smaller cylinder inserted into each other, and such that the walls of the cylinders are parallel to each other, and the space in between is uniform throughout the circumference of the two cylinders. Now, when you have that, it's also designed in a way that the inner cylinder has opening. If you look at my whiteboard here, the inner cylinder has opening whereby the fluid can enter into the space inside the bigger cylinder. Now, with that design, a high frequency electric signal is introduced to the probes. This middle, part is a metal, and the inner cylinder is another metal through which the electric signal is introduced. When the signal is introduced, high frequency signal, it develops a capacitance between those two parallel plates. So the capacitance developed is a sum total of two capacitances. The reason why we have two capacitances is because we have fluid in the tank and then we have vapor or air on top. The vapor serve as a dielectric, the fluid also serve as a dielectric. But since we have fluid with a different value of density, the vapor has another density. So for that reason, the dielectric between these two portions are different. And for this reason, the total capacitance will be sum of two capacitances in series. The one due to the liquid in the tank, the lower portion, and you see this green dot is the vapor, indicating the upper portion of the tank, whereby we have vapor or air. Now this vapor causes another dielectric to be introduced into the tank, causing another value of capacitance to be developed from the portion the vapor exists to the upper part there. So the two capacitances are now in series. So the total capacitance C is a sum of the capacitance at the lower portion due to the liquid and the capacitance at the upper portion due to the vapor. Now summation of those two give us the total capacitance, and then it's written in the formula that I did not complete here, that is in your your notes, your handouts. So when you check that, you see that there are levels, height for liquid, height for vapor. And so from that formula, height for liquid can be determined, can be made as subject of formula and calculated when other parameters such as the permittivity E naught, permittivity of liquid, permittivity of vapor, and the radius inside the tanks are known. So that is how it works. So with the value of the capacitance measured, then from that formula, the total height of the liquid can be calculated. As simple as that. It's also a very good system and ingenious way of measuring, liquid level. All right. So that is what we learned today, and that's where we are going to stop. I don't know whether there's any other question. Absence of any other question, then I'm going to bring it to a close now. After which I'm going to, copy the link and forward to your class rep. Your class rep will now send to your WhatsApp group. Any other question, please? Question, please. If there's no question, we're going to call it a day. If there's no question, we are calling it a day. If you have any question, please type your question in chat now. Let me respond quickly. So I wait for some few seconds to see your question. All right. Those that just came in, you can actually type your matriculation number. Let me see it on the screen if you have not done so. Those that have typed before, I've copied it. If you have not done so, you can type your matric number right now so that I can know that you are present. The matriculation number will indicate to me that you are present in this class. I've copied all of those that have typed before. If you have not done so, you can do so now. So waiting for your question, please. Waiting for your question, please. Okay, I've not seen any new question here. So for that reason, you are indicating to me that everything is well understood. Okay, so we may not wait any further. We may not wait any further. So, but I will still wait for some few more seconds in case somebody is typing and is delayed so that I can respond. I will wait for a few more seconds. Okay. All right. So I have not seen any other questions. So, oh, very good question. Is the permeability for all liquid the same? That's the question coming from Gospel Pilot. All right. Now that's a good question. The permittivity for different materials, you know, is different. It's not the same. Permittivity is not the same for all liquid. Permittivity of, let's say, oil is different from water, it's different from fuel, like petrol, kerosene, and so on. Even permittivity of paper, permittivity of wood, sand, they are different. So different values of permittivity. And that's why in this capacitance method, we are talking of different permittivity. Apart from the constant permittivity of free space, epsilon naught, we have different values of permittivity for the liquid and for the vapor. It's in the formula. You check the notes now and you see all those parameters in the formula. So thank you very much for that question, Gospel Pilot. Now with that, I'm ending the live class. So I say bye-bye to you all. Bye. Until next time. Can I see your bye-bye? Can I see your bye-bye too? Can type your bye before I end it. Okay. So until another time. All right. Thank you, Ajiboye. Thank you, Ajiboye. Bye, everybody. Ending it now.